You're staring down a practical data question in your Cambridge IGCSE Physics 0625 paper. The clock is ticking, and you absolutely need to secure every single available mark. We're skipping the basic textbook definitions today and pulling off a mark scheme heist. We are going to reverse engineer the examiner's mindset to see exactly what gets rewarded and what gets ruthlessly penalized.
Imagine you've got 3 doors in front of you. You need to measure a really short time interval, like the time it takes for a pendulum to do one quick swing. Only one of these doors unlocks the full marks in your 0625 exam. Door A says, take one quick stopwatch reading. Door B demands taking the average of multiple readings. And door C, just a visual estimate. Pick the wrong door and you're instantly risking grade boundaries and dropping marks you should absolutely be keeping in your pocket.
Well, spoiler alert, door A is a massive trap. It leads straight to one of the most painful learner mistakes in all of physics data analysis, relying on a single measurement. Choosing just one reading leaves your answer incredibly vulnerable to massive error margins. Why? Because honestly, any single measurement in a physics experiment is never going to be perfectly accurate. There's always an inherent error or uncertainty. If your reaction time is even slightly off that one single time, your entire calculation is totally compromised.
To really grasp why this precision is non-negotiable, picture the flight deck of a passenger jet. It's packed with measuring instruments giving the crew critical data about the aircraft's performance. Just like pilots relying on those dials, your physics answers demand absolute precision based on a chosen standard unit. Before you even make a measurement, you have to choose a standard unit and then find the size of the quantity using an instrument with a properly marked scale. You can't be vague when flying a plane, and you sure can't be vague in your exam. Now, there are 3 basic quantities we measure in physics to build this whole foundation: length, mass, and time. Every single other unit you're going to encounter in your syllabus is built on these 3 foundational pillars. The SI system, the metric system we use, takes these 3 basics to build all other units. And because it's a decimal system, these units are super easy to divide or multiply by 10, giving you smaller or larger units depending on what exactly you're trying to measure.
And that perfectly brings us to the powers of 10 shorthand. It's a beautifully neat way of writing really large or really small measurement numbers, which is an absolute lifesaver when you're rushing against the clock in an exam scenario. Look at the magnitude here. 4,000 is efficiently written as 4 times 10 to the power of 3. On the totally opposite end of the spectrum, a tiny decimal like 0.004 is written as 4 times 10 to the power of -3. Nailing this shorthand stops you from losing those annoying trailing zeros and saves you precious seconds during complex calculations. Now stick with me through this explainer, because missing the upcoming vector clue is a guaranteed mark dropper. In just a moment, I'm going to show you the exact examiner clue that changes vector answers completely. But first, you absolutely need the core measurement framework that makes that clue utterly obvious. Without this framework, even students who have memorized the formulas perfectly still fail to secure those top-band marks. Okay, let's break down this answer framework. When you're tackling data analysis or practical investigations, applying this exact 4-step framework forces you to think exactly like the examiner. Step 1, identify the underlying physics concept. Step 2, extract the exact evidence or data from whatever table or graph you're given. Step 3, apply your scientific reasoning to connect that concept right back to the data. And finally, step 4, output your final answer using precise examiner wording. Run your practical questions through these 4 steps, and you literally leave the examiner with absolutely no choice but to give you the marks.
Let's actually see this in action. Take a look at this flawed student answer for figuring out a small distance. Take one measurement. As we talked about earlier, this completely ignores the inherent error of simple devices. Now contrast that with the top-band approach. Take the average of several measurements, or measure multiples. If you want to massively reduce the size of the error for a small distance or a short time interval, the top-band approach is always to take the average. Measuring multiples, like timing 10 swings of a pendulum instead of just 1 and then dividing by 10, totally smooths out those pesky reaction time errors. Now, what's really fascinating about this flawed answer isn't what's there, but what's completely missing. Think about this statement. The volume is 45 and the time is 2.5. Spot the error for me. What is fundamentally wrong with this final exam answer? It's a huge trap so many students fall into when they're rushing. There are no units. In physics, a number without a unit is completely meaningless. Are we talking 45 liters or 45 cubic centimeters, 2.5 seconds or 2.5 hours? The SI system demands that you always state the unit right alongside the numerical value.
Seriously, never leave a number naked on the page.
So this brings us to the crucial examiner clue I promised you earlier. It is the fundamental difference between describing space and time just with numbers versus describing them with direction. Scalars are physical quantities that only have size or magnitude. Think of mass or temperature. But vectors are physical quantities, like force and velocity, that have both magnitude and direction. Recognizing this difference completely changes how you handle the data, especially when you're trying to combine them.
Let's put this to the test with a quick interactive challenge. Pause and predict right now, how would you calculate or graphically figure out the combination, which we call the resultant, of two vectors that are at right angles to each other? Let's say you've got a force of 3 units pulling north and a force of 4 units pulling east. If they were just scalars, you'd probably just add them up. But they're vectors. How do you find the exact resultant? Really think about your answer here, because the examiner's rulebook handles this very differently.
Here is the exact examiner-style correction. You literally cannot just add the sizes of 3 and 4 to get 7. Because they're vectors, the strict rule is that you have to take into account any difference in their directions. You've got to first consider both vector sizes, then account for their perpendicular directions, and finally calculate or draw out the resultant graphically. Using a scale diagram or math calculations is the only way you're going to find the true size and direction of that final combined vector. We're nearing the end of our heist here. But before you hand over your paper or finalize any data table or graph scale, you have to run through a final practical checklist to safeguard those marks. 1. Verify your units are actually there and correct based on the SI system. 2. Check your significant figures. 3. Make sure you've stated the correct variables, especially knowing the difference between your independent and dependent variables. And 4. Evaluate your uncertainties by double-checking you've used averages or multiples where you're supposed to. We've successfully secured the measurement marks and pulled off this section of the heist, but there is still a massive unresolved problem waiting for you in the escape tunnel. You know how to handle the data now, but what happens when the examiner suddenly shifts their command words? The specific traps hidden inside explain, describe, and evaluate questions require a totally different strategy. Falling into those traps will instantly cost you exactly the marks we just worked so hard to steal back. Door 2 opens in our next explainer. To open that next door and dodge those specific question-type traps, you have to master the subtle language of the examiner. You've got the measurement marks, but ask yourself, if an exam question says evaluate instead of describe, do you know exactly which words will cause the examiner to withhold your final grade? Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations.